the chain.
Welcome everyone to another episode of The Chain with your host Armel Nene. Today joining us on the show is Lucas Käldström, who is working for Weaveworks, a Kubernetes and ambassador for the Cloud Native Computing Foundation. So first of all, welcome to the show. Lucas, how are you?
Hi, thanks. Thanks for having me. I'm very well. Sitting in a small town in Finland called Jakobstad. Small, 20,000 people. So.
All right, 20,000 people.
Yeah, it's good. But it's summer here. It's close to up north, so close to the Arctic Circle. So we have a lot of sun these days.
Oh, must be a nice time. All right. So you want to tell us a little bit about yourself? Who you work for, what exciting stuff you're currently working on. Right.
Absolutely. Yeah. So I'm currently working for Weaveworks, and I have been doing so since approximately 3-4 years now. I got in touch with the Kubernetes community for now a bit more than 5 years since, and yeah, it's been quite a ride. So I started by, and what some people know me for is that I ported Kubernetes to ARM. So Kubernetes 5 years ago was something which it was in its 0-something releases, unstable, and not yet this community like explosion, like with whole world engagement. So by then it was a small Google project by some people, and they had a lot of good ideas, but yet to bring it to the masses. So one of the things now I'm also studying university, first year student there, and by the time I got in touch with Kubernetes, which was also pretty exceptional in some people, was that I was 15. So I started working with Kubernetes and then engaging with the community by 15. And I then ported Kubernetes to ARM, which the Googlers never had thought of even. And I wanted that because my Raspberry Pis, I had a set of Raspberry Pis, but I didn't have any, other laptops and computers I could just destroy, like we needed for other stuff, obviously. So the experimentation was left to Raspberry Pis, and Kubernetes didn't work. So I made it work. And
how old were you at 15?
A lot of fun.
Right.
Yeah. Obviously, it took a couple of months of research and stuff, but yeah, and then I made this Kubernetes on ARM project. I published it to GitHub. It was essentially a set of bash scripts and make files and Docker images, to put all of the pieces together so you could run it. Also, writing SD cards with custom ARM kernels and things.
So you managed to,
and yeah, people. Yeah.
So you managed to make Kubernetes run on your Raspberry Pi.
Yeah. Right.
All right, and that was one of your first projects, and that's how you got into Kubernetes?
Yeah, so that's how I got into it, and also that's how I got into the open source community. I hadn't engaged with open source before, and but when I published this Kubernetes on ARM project, and suddenly, like I remember this first time when this French guy, hit up like the issue tracker and said like, hey, this is not working on my whatever other board, Odroid or something, and I was like, oh my God, amazing. This one person looked at my code and he liked it, but he wanted to make it even better. I was like, oh my God, this is, I've never experienced that kind of
that must be
thing
a
before.
Really good feeling.
Yeah, it was a really good feeling, yeah. So, and people got pretty interested. So I decided that this is something which should be in Kubernetes core.
All right, so that was incorporated
from there.
Oh, really good.
So then,
that's quite impressive.
Yeah,
right. It's quite impressive. Trying to make Kubernetes work on your Raspberry Pi. So I'm sure it becomes as a side project or hobby project, right?
Yeah.
Now to having that code as part of the core Kubernetes distribution, right?
Yeah. So it was approximately half a year from that I published the open source, the Kubernetes and ARM, my side project, hobby, to like half a year until I had all of that merged into core. So not a huge time frame in, like,
but it's still impressive.
Considering everything should be there.
It is still impressive. I mean, the guys from Google with all the millions and billions did not think of that. Right. So that's a very good, and I guess that's how you were introduced to the Cloud Native Computing Foundation, because you're an ambassador there.
Yes.
Right.
Yeah. So my first PR was merged in December 2015, and this was around Kubernetes 1.1 time frame, and yeah, I just started shooting a lot of PRs, like all the time, and say like, here, I want to fix this, and there's a problem in the build script and stuff, and the Google guys, and also at Red Hat and CoreOS as at this time were the three main parties involved this early, and they were like, oh, this person contributes a lot, and I didn't know how open source really worked, so I had, I didn't have an avatar. I just had my name and, Finland, because I was not afraid, I would say, but unsure if people would, like, be biased. So that, but yeah, I started shooting a lot of PRs, and people were happy, and I got some also responsibility and became a maintainer approximately in the spring of 2016. A maintainer essentially means that you have, write access to the repo and can merge things and stuff like that. The role doesn't exist anymore because then Kubernetes, grew so big. So like there's no way, like a single person could like watch all the things which goes into it.
It's too big now.
And then, yeah, it's so big. So now we have fine grained. So like people have write access to their own folder essentially, and and that's now instead called sub-project owner. But anyways, I got a maintainer by spring 2016, and yeah, this was my first year in high school. So it was pretty interesting journey.
That's impressive.
Then
right?
I helped.
I mean, first year, especially in high school, you start a side project on our Kubernetes to make around a Raspberry Pi. A year later, it gets incorporated into the main Kubernetes distribution. And all that within the second year high school, or is still the first year high school?
It's still first year, yeah.
I mean, how many people can achieve that in the first year high school? That's amazing. That's really amazing.
I also gotta say that I mean, obviously there's luck involved, that the timing happened exactly. I discovered the project right in time when it was super early, before it was like even considered at all stable. But yeah, anyways, yeah, it was a lot of hard work indeed, but I thought it was fun, so that's why I did it. And what I used to say also is that, like, when I really saw the project from the first time, it was like, oh wow, a teenage boy, like, we're interested in tech, like whatever Google does, you think it's nice. Not really, but kind of like if you see something which is done by the
So were you already familiar with coding?
Yeah, sorry.
Were you already familiar with coding?
Yeah, so I had done coding for a couple of years, maybe 3 years, but I hadn't done this kind of open source. I hadn't done any Bash, any Linux stuff really. So that was new to me. But yeah, anyway, so it was like, I was impressed by the, Google is doing this in the data centers, I want to do it on my like desktop too. But from there it kind of evolved to, and this is what's so nice about the community, is that the more I got in touch with different people, the more you know, and still, you know, just having my avatar closed and everything, you know, but the more welcomed I felt, you know, like people actually were, yeah, nice that you're with us. Like now, let's go build something great. So I really like that spirit, and I believe that it still really is inclusive community, and that the founders, you know, strived hard to, you know, be the role models of that kind of workings. So like, and set the values and stuff like that. So I really like that. So for one of the ones to have influenced that kind of thing really a lot is Sarah Novotny. And these days she's at the CTO office at Microsoft. By then she was open source manager at Google. And from there, yeah, you know, if you've tried Minikube sometime.
Yep, I'll go Minikube running here.
Yeah. So and the funny thing here is also that I didn't know Go. So I did all of these Kubernetes to ARM porting without knowing how to write a fully fledged Go program.
So I will make a very rubbish joke and say you learn Go on the go.
Yes, that's exactly how it happened. Because when I was kind of done with our ARM stuff, I was like, okay, so what's the next thing? And then I found Minikube, that people started Minikube and got the idea that we need to have something, you know, on the laptop which runs well and has a good user experience. Because by this time, you know, Kubernetes was something which could only kind of be, it was only possible easily to run it on Google Cloud. You couldn't run it really anywhere else without, you know, a lot of pain. So that was one of the next incentives for me, that now I want to make it easy for people. Now that I kind of understand how the pieces fit together, now it should be easy for users to get started. Easy, obviously, you know, like still there's complexity, but as easy as possible. And so then we started Minikube, and that was my first Go project to start hacking on that. But just a few months later, I found out that KubeADM, we, you know, like engaged with that and started building KubeADM, because Docker Swarm had this Docker Swarm init and Docker Swarm join, which they announced at DockerCon that year, and this was 2016. And then we were in Kubernetes like community, like, well, we should have the same kind of user interface. Like that's amazing. We want to have the similar for Kubernetes, and then we came up with Joe Beda, for example, and then Alexis Richardson, which is the CEO of. So Joe Beda is one of the founders of Kubernetes, and Alexis Richardson is also really early involved, has been in the TOC in CNCF, so Technical Oversight Committee, and is the CEO of WeWorks. So they started, you know, and other community members thinking like, well, how can we do the same? Because again, Kubernetes was something which really only could be installed on Google Cloud by that time, but it could be, you know, so much more. And yeah, then they put a proposal together, you know, with other people, and I was like, really, this is what I want to do, like, because eventually KubeADM is in a part of Minikube. You know, these days it's like Minikube is running a virtual machine, and inside of that you run KubeADM. So I went from doing Go or Minikube to, you know, directly working on the inner parts of you know, the foundation of all the Kubernetes cluster install, because I was really interested in the cluster lifecycle. And now, well, there I am. So then I, you know, and again, this was my hobby at the time. So I started working on the cluster lifecycle stuff with KubeADM. I shipped that. Actually, also merged KubeADM to core because I had maintainer privileges. It's a funny story when, you know, like on the way to my maths exam, I walk up the stairs and like I LGTM the thing into into being merged, and we off the release went. And
yeah,
that
kind
of,
your exam.
stuff.
Yes. You should be focusing on your math exam.
yeah. Well, the math exam went well, anyways.
That's very good. Yeah, sorry, you were saying?
Yeah. No, go on.
Yeah, so you were there from really to see that you were involved, passionately, because it's a passion.
Yeah.
Get into the whole Kubernetes project. But look where Kubernetes is now. You have very big companies joining. Obviously, Google, one the largest one, but a lot of companies, when they're talking about new architecture or deployments, they always think about Kubernetes, regardless that it's running on GCP or AWS or Azure, right? So now, one of the simple questions, right, for the audience there is, what is the whole fuss about Kubernetes, right? What is the fuss? Why can we not just run on bare metal? What does it solve that we can't actually do with bare metal with the current cloud providers that we have?
Yeah.
Right.
Yeah. So that's a good bridge to like. So before I introduce the cluster lifecycle stuff, which is the next thing, which is what KubeADM will do, I can talk that like, what did I get out of? So I maybe share my perspective of, okay, I had a bunch of Raspberry Pis at home. And, other than the coolness of running Google software, what did I actually get out of installing Kubernetes there and doing it? So there's a couple of different things. When I looked at, so I wanted to put my Raspberry Pis to work. And I believe that we all want to make, we want to put our computers to work. That's what they like consume energy, and like that's why they exist. So they do computation. But the problem was that like, how can I, in a good way, say that, okay, I have 5 Pis. Say that all Pis do like calculations on Pi as much as you just can do it. And if this, if you got a power outage, make sure that the calculation doesn't get lost. Like, make sure that you snapshot your work, and like, if one of the Pis go down, make sure that someone else picks it up. And how would you traditionally do that? Or say that like, I have a set of web servers running on these Pis, and I want to achieve like a throughput of, say, 100,000 requests per second, and that really requires all of the Pis to be achieving the full steam. And if I mean, hardware is bound to fail, so how would I programmatically do that so that if they and when they fail, how can I rearrange the architecture of the thing? And I looked at a couple of different alternatives. For example, MPI. So now I don't remember what it stands for, but basically what's used in scientific processing. When you have to shell out a lot of different things, and then you map reduce stuff. For example, or Hadoop or something like that. But, they never really felt like the right abstraction for me. So because like they are not so general purpose. It's like, if you want to compute Pi, yeah, it can do that. Or if you want to search through a list of all kind of data structures and then get back to a single result. But if you want to run a web server, if you want to run some APIs or databases or whatever, it doesn't really fit. So what is then the right abstraction for having a sense of automated infrastructure? So how can I tell my Pis what to do and they will figure it out? That is the kind of the question. Like, and traditionally you'd solve this by writing a lot of bash scripts. You have a load balancer somewhere, and you make sure that you have something pinging different things, and like rewriting some shell configuration when things fail, and then you have to manually SSH into stuff and reactivate services and these things, and this is really what Kubernetes solves. So because now what you're essentially doing is that you're treating every machine, so every physical piece of hardware, you're you're seeing that thing as stateful. Well, you're seeing it as a stateful thing, and you're seeing it as a mutable thing. And actually, that's two of the things which Kubernetes don't want to do, because it has problems with that. If it's stateful, then you can't just move over easily different things, and you have no way of automating that. Yep. Yeah, and if it's mutable, then you gotta SSH in there and do something for it to work. So the idea with Kubernetes is that if we put a higher level abstraction, and if we look at all of these pies, there are 5. Look at them as one unit. And if we look at them as one unit and they expose theoretically, hypothetically, some API. So I as a user or administrator, I can tell the thing to, like, go do this. And then in computing, there's often two different types of, triggering. So like, how to say that in an easy way. So like, either when you're one party and want to send some signal to the other one, you can either, send one single thing, which is, if the other party is, like asleep, they won't get the signal, right? But if you instead constantly signal, so say that it's a 0 and 1 pulse. So you send quickly 1 pulse, it goes to the other and it's asleep, so it doesn't see it. But if you constantly send 1 until, so that the other party will see that, oh, this is sending me alerts all the time, then they can take action on that. So that is one of the ideas that is called level triggered, and that is one of the ideas that if you having that API, whatever it is, if you have some kind of API where you store what should the desired state be, and just think about nothing else. Just say that, I say that there should be, 100, or no, so 100 applications running. I say that there should be 100 web servers running on my pies, and that's totally possible. I should say 100 should be there, and then like Kubernetes can look at that and see that, oh, this user says that there should be 100 web servers. Now what can I do to make this true? And then we have the nodes have these kind of act loops. So they all constantly look for, like, this is a mega long for loop essentially, and which checks like, what is the desired state? And then I compare it to, is it the actual state? Like, is this what I'm actually doing? And if they don't match, then I take some action. And this is, it's a fundamental idea in the system that like we have these, we call them reconciliation loops. Because traditionally what would happen is that maybe you put stuff in Ansible in a Git repo, but it's the user who needs to, imperatively execute them, and instead we declare declaratively the desired state. We put it in somewhere, and it's in the API, and it's the actuators. It's the like nodes, for example, then job to make it happen sooner or later. But it's that kind of. And now what we've ended up with is like we have this abstraction of the whole cluster. So we can just, we can just tell the cluster what to do, and it will try to do that as its, sole purpose in life is to, make the user happy. And then that's a fundamentally different thing. And it gives the user, a lot of power. It gives like completely new, because we have this new abstraction layer, gives completely new possibilities to write distributed applications and just like normal automate way more than before, because now you're not as constrained to the environment. If I install Kubernetes on Raspberry Pis, it works exactly the same as if I would in Google Cloud or Amazon or on bare metal. which Raspberry Pis kind of are.
Yes.
So at the same time, but like it as we have the same API for all of the places, we can write once. Like a good example is a certificate manager. So I think talking to Let's Encrypt, getting certificates and storing them in the Kubernetes API, then we can use that for web servers inside of the cluster wherever we are. It's not a problem. So before you'd have to, like, oh, if you're using Nginx, do that, or oh, if you're using Trafic, do that, or if you're using that or that or that, and then multiply that matrix by every environment, and that's a mess. So, but when we have this new abstraction layer, we are, completely, we can take the productivity to the next level.
Well, automation is really good, right? But with such a complex system, you're gonna have some issues. So things around networking, right? How does networking work? For example, I'm writing an application and it needs to be integrated, right? So you need to know what other services are up and running, so service discovery and the likes. So, how does it work in Kubernetes, especially the networking of discovering new services and registering new services?
So networking Kubernetes is actually just third party. So there's, and here's the thing with Kubernetes, it's really extensible. Because it works in all of these environments, it gotta be extensible, and it gotta, instead of working, like having built-in workings for every place. So like, consider cloud providers, and now shortly going to another, but like, I will answer your question. So, but think about cloud providers, for example. If we would in Kubernetes core have cloud providers, integrations with their stuff inside of the Kubernetes repository, like inside of the core Kubernetes project, then there's a million cloud providers out there, right? So then we would receive a million of different contributions just for making that cloud provider work, and that doesn't scale. Then we have a gigabyte binary, because of all the integrations to different places. So what do we do instead? Well, we define an interface. We define that this is the way you interact with the system, so you can make these features work, right? Without having to build in them in the core. And networking is working in the same way. So Kubernetes defines, or actually it's another CNCF project, which is called Container Network Interface. So it's a small JSON specification which defines like, what does a container network look like? What parameters should it have? What kind of schema is there? And that kind of, how do you trigger it? And then Kubernetes integrates with that. So if you want to have, if you're running a web server, for example, so you say that, okay, run my 100 Nginx web servers. Every node has its own subnet, and Kubernetes schedules the different things to the different nodes. Okay, so if we have 5 nodes, maybe 20, 20, 20, or probably it won't be even, most likely, but still. And then on one node, we now have 20 applications running, okay? And then from that, the node agent or node daemon or whatever you call it, it's called kubelet, is talking to a network provider. So that using the CNI interface. So every time an application is going to be started, it asks the CNI implementation, the network provider. It asks like, hi, can you give me a new IP to use? And from it should be using this subnet, but give it somewhere here. And then the CNI implementation responds that, well, here you go. And then with this, we have a great flexibility, because if I probably want to have some network which is different on my Pis than on Google Cloud, where things are maybe even wired by, not by hand, but like actual wires, and that kind of stuff. So like where the networking topology looks really different, or on Amazon or on Azure. So that's why we have the need for that kind of extensibility. But that extensibility, as it translates to most of the parts of Kubernetes is seen and is a complex piece of code, because you can never, if we would be really opinionated and say, well, Kubernetes is a thing which does all of these great things, but it only works on 3 nodes on Google Cloud using, Ansible scripts, and using this network, and it has only this load balancer. And if you would pick one of these, this thing, and just check some boxes and consider that's it, then for the rest of the world, it's like, what's the point? But now that would be easy for the user, and wouldn't have too many knobs, possibly. But then it doesn't help anyone else. So that's why Kubernetes is a complex piece of code. But also that's why actually we in the CNCF community and in the Kubernetes community, we also encourage people to build on top. Because now that we have this great API, which is also gotta say that the API structure is groundbreaking. It's an innovation on its own. Now that we have this API, we can start building platforms on top of that, which make some of the choices here. We support these different environments, and we provide you with a better ways of working. So getting now that's to answer your question first.
Just one part missing out of the question is I know there's a service mesh project from the CNCF.
Yes.
Right. So for discovery of all new application services, right? So let's say if I write a new microservice, right? And I wanted to scale. You mentioned earlier, use Nginx as an example, where you could have multiple instances of the application running. And how does the application actually register and knows that it has to call, for example, a database, right? So, but I think you kind of answered it. But
so service mesh is different, and it kind of service mesh is one of the things which so take it as this. So we have, what kind of abstraction layers do we have in computing these days? So we have zeros and ones in the processor. Then we probably have assembler somewhere, and that. Then we have stuff like C, and going high level. Then we have and with C you can do or say Linux. Linux is a better example, and Linux controls the hardware, all of the the graphics and the CPU and memory and disk and whatever, and that's an abstraction layer for the hardware. That's an abstraction layer. An operating system is an abstraction layer for that piece of stuff. I don't know what. So that piece of hardware, and it doesn't then really matter. Well, in some 1% of the case it does, but it doesn't really matter generally. If you're say on a small Intel Atom something computer, or if you're on a beefy Ryzen server, you can do the same kind of syscalls to the machine, and Linux will translate that to whatever it's actually should do, right?
Yep.
And that syscall interface, so system calls interface, is an abstraction layer which is powerful. And Kubernetes, you can think of an abstraction layer for a set of these machines, regardless of their running Windows or Linux. I think that I haven't tried the Windows stuff, but they would be fun because they say it works, and and it's part of also the multi-platform stuff.
There are some people who try the Windows.
Yeah, but anyways, it's an abstraction layer for that. So a set of machines, and now if we have these in the similar way syscalls, because So yeah, so getting back to the syscalls on Linux, why doesn't people, you know, just write, you know, these syscalls? Why don't people just, you know, write C all the time? And why would people even do JavaScript, you know, when they can just do fopen and like truncate and whatever, and like things it's extremely complex just to, you know, show a file. Why would people use JavaScript? Well, it's because it's so much easier, right? And it solves a lot of problems which, or like solves a lot of complexity for the user compared to if you would use C, doing the direct syscalls. And you can think of Kubernetes the same. So like Kubernetes had a set of primitives, it has a set of APIs, a set of syscalls. And if you're not familiar with this and you are not interested in building like really, you know, low-level stuff in so to say, directly talking to Kubernetes, maybe what's better is that, you know, you use a platform which has, you know, it's essentially the V8 JavaScript runtime, if you like, which translates all of the nice JavaScript to the ugly C. You know, you see what I mean? So like it's some kind of, and in the same way, you know, you have a lot of nice manifests or nice, you know, user interface, which you feed the platform, and the platform on top of Kubernetes, you know, translates into all different things and a million different Kubernetes objects. And then the million different Kubernetes objects translate into like what Kubernetes should do in that environment. So that's kind of how you could see on it. And that's why we call Kubernetes to be a platform.
Okay.
A platform for building platforms. And now, as it happens, Service Mesh is one of these platforms. So what problem does Service Mesh solve? Well, now that we have this set of APIs which Kubernetes provide, we started thinking that, well, how, you know, like if I have an API which talks to a database and I have a front end, so I have front end, back end, and database, and now I need to secure with mutual TLS all of these parts, right? And I have to, if I send something from the front end to the back end API, I probably need to, you know, like if the request fails, I probably need to retry it a couple of times. And, you know, I need to, if the stuff is temporarily unavailable, then I maybe need to do some backoff. And you know, if the network is unreliable, I need to do something else, and et cetera, et cetera, et cetera. And people discovered that, oh, well, we do kind of all the same things. You know, like say one is in JavaScript and one is in, you know, Node.js, sorry, no, Go, and one is maybe a SQL server. And then they need to, in different languages, build in the exact same mechanism. So what if we could, using the Kubernetes primitives, using some container magic, if you like, in the network layer, what if we actually could build in all of these things, all of the pipes? Could we make the pipes between the applications which are running in Kubernetes smart, so that the pipe itself will retry a request if it fails, or the pipe rate limits stuff, you know, on demand, or stuff like that, and the pipe provides mutual authentication and trust and encryption. So that is one of the interesting things which you can do only if you have this abstraction layer from before, which Kubernetes provides. So then you can start thinking about these higher level things, and then things. I mean, obviously, Kubernetes comes with its own set of problems. We talked about that complexity, for example. Yeah. And obviously, Service Mesh comes with its other set of problems. What happens if that service mesh goes down? And stuff like that. But still, it's an interesting idea, and I really encourage people to start thinking about what is possible when you can, you know, step up that abstraction layer. And yeah, so how and getting back then to what I did inside of the Kubernetes community after the ARM stuff was that, you know, I started working on KubeADM because I was really interested in getting Kubernetes accessible to as many people as possible. So like it wouldn't be only this, Google Cloud deployment. And I engaged in KubeADM. I helped make it, make it into the project, like make it good. And then by this time I had got a few amount of job offers. All of them who was, most of them who was, like automated, recruiter, just automatically sending out, and only offered full-time jobs and stuff like that. And mandatory relocation and stuff. And it was like, I was 16. It's like, what do you want me to do? But then WeWorks was really, Alexis Richardson was really nice and like understood the situation and wanted to collaborate in a way that made sense for both. So I have my, company in Finland and then do contracting for WeWorks ever since. And my task was to, make KubeADM this, say, industry standard bootstrapper, like deployment engine. So that, regardless if you're starting a cluster in Google Cloud or in Amazon or in Azure or on your Raspberry Pis or bare metal or whatever, you can still use the same thing. And, it gets you from that you have the machine up and running, the machine has booted to the machine has Kubernetes, but nothing more. Exactly just that piece of code, because that is critical in that it needs to be done everywhere. And you need to install Kubernetes somehow if you're going to use it.
Yeah, definitely.
And so I was tasked to do that, and I spent then approximately 2.5 years until we had that from alpha to general availability. And it was a lot of fun. I've enjoyed my time at WeWorks, and now like what we see now is that now when KubeADM is kind of done, there's this next thing called Cluster API, which takes things one bit further again. In the same way as when we have Kubernetes done, it's not never done, but done enough, people start thinking about what is the next service mesh. And yeah, the same thing happened with KubeADM. So now that I helped get KubeADM to a state where it's stable, it's working, it's used in a million different places. Now we can think of the next thing. Now we can broaden the set of abstractions and like platforms that we target. And now we can see that, one of the things like my contributions, for example, helped so that, being a good open source citizen is really important too. Like you don't, as a company as WeWorks, for example, you just don't you don't take one thing from the open source community and kind of steal it and into your product and just ship it. Instead, you actually collaborate with the community. You make things better for the general good. And then when you have done that, you can build a product on it, but you make sure that the freeware is it's out there, or like the open thing is there, and then you customize and build a specialized product. As I said, you pick some of the stuff in the matrix and you sell that to customers. But as you have already made the choices, it's actually a way more easy to navigate. So now they have this Kubernetes enterprise Kubernetes product, which is building directly on top of KubeADM, and the Cluster API, which we made in the C cluster lifecycle, where I then was a lead for a co-chair for a bit more than 2 years. So so that kind of also says something about the business model. What is a good business model? Well, it's one where you actively engage with the community. You make things better in the open general good. By that, you have some kind of reputation. Like WeWorks was now named the eighth highest contributing company, and to Kubernetes, and the others are giants like Google and Red Hat and and Microsoft and that kind of, and then one startup. So that was pretty amazing to see. And yeah, but like cloud native, to me, it resembles around these things, which gets back to your initial question more. So like having this, you know, reconciliation loop, having this like retry until you succeed kind of pattern, and make sure that you signal to everyone that now nothing is wrong. Now something is wrong all the time until they fix it.
Mm-hmm.
And make sure you sync this. And, you know, this can be seen in WeWorks. So WeWorks also innovated with some things like a couple of different projects, not like on top of Kubernetes. So, for example, one of those is Flux, which is now also a CNCF project.
Okay.
So, which is the way of using GitOps. I don't know if you have heard the GitOps term.
Yes. And
yeah,
I also saw that you have it on WeWorks website actually.
Yeah. So that is really interesting to me because you know, now that you have this you know, in these cloud native patterns, so that like now that you have this box to which you can send like, here is what I want you to do. What is then a good way of doing that as in a team? Is it that, you know, like you have 10 people, you're all the 10 people are looking at the same box, and they all tell the same box that I want you to do that and I want you to do that, you know, like, is that a good way? And then you just look on the other side, what did it actually do? So GitOps addresses some of those scalability limitations, if you like, and also security boundaries by using a tool which, you know, developers already like, and which, well, most of them at least get, and then, but at least are familiar with the flow. So like, if you now think of such a thing that, you know, you say that I want to do this, and you check that into Git using the same, you know, APIs as you would to the Kubernetes API server, but you say to you post that into a file in Git and say that this is the configuration I want to have happening, you know, I want to actually have running in my cluster at this time. And then you have some automation loop, again, level triggered, automation loop from the Git repo to actually actuate into the cluster, you know, to make that kind of, and then you get these kind of, you know, then if you declare the desired state there, you have some extra control on the process of, you know, delivering stuff to your cluster. And that's pretty interesting, because then you can also, you know, if someone, you know, a malicious old like employee that left and kept his or her, you know, like credentials, yeah, then they would go in, you know, and like start running stuff on the cluster. Then that, you know, you could actually see that by taking the difference of the desired state in Git and the actual state in Kubernetes. You can actually see the difference there, and, you know, start firing alerts. So it's like closing the loop on that kind of thing by having some, because Git provides a lot of good primitives, like, you know, having a time-based and authentication-based, you know, track of record and et cetera. So so that and many others. I mean, we can't talk about all the cloud native patterns, unfortunately, during this talk, but discussion. But like, they're highlighting some of the key ones, and that is, you know, the API, having the declarative APIs and the reconciliation loop, and making sure that using those, you can actually build on higher level primitives in a pretty sophisticated way, so that you can start thinking about, you can start automating things you could not before.
I mean, that's definitely good progress, you know, where we come from having one single box to having a cluster box, even though you managed to run Kubernetes on a Raspberry Pi, so which shows that you can run anywhere, bare metal or in the cloud, which is really good. And just conscious of not taking too much of your time, but one more question is, you know, what do you see the future is for Kubernetes, really? and cloud native?
Yeah. That's a good one. We'll see. But yeah, I mean, I have some ideas, and one definitely is going to be, even more extensibility. I believe that that's going to, keep doing. I think that Kubernetes with time will, and I took the cloud providers actually as an example. And said that this is nothing. This is something which definitely shouldn't be in core. Mm-hmm. There should be an interface and cloud providers on one side and Kubernetes on one side. This has not been true, and this is not kind of yet really true because Kubernetes 1.0 shipped with, I think, 6 different cloud providers integrations. And it was a mess because there would be other cloud providers then who came up and said, oh, we want to also contribute code for our thing. And, here's 50,000 lines for you to review, which makes the binary an extra 50 mega across the board. So, it has security implications, but a lot of more scalability just in terms of project. And now Kubernetes has I don't know, 35,000, maybe 40,000 soon contributors. So I mean,
that's pretty large.
That's pretty large, and you can't have all of the ever things that are there. So that is one of the things which, I mean, we've started the process more than 3-4 years ago on extracting those cloud provider code, which we identified they don't belong here. They were put in, before we actually had a clear design on how to do things. And now we need to design to pull it out and make the interface. So, and that's pretty much, it's soon done, but it's been a long way there. But I think that this is a pattern which will, kind of over and over again be repeated for different parts. So we had an initial set of assumptions that, maybe it's good to bake in the cloud providers, which turned out to be false when the project grew. And I think that, as the project grows even bigger, there will come up many more such things. So that's one. Then we have, I do believe in the cluster API stuff that I talked about.
Yep.
And it's essentially an API which defines, if we really simplify it, it defines one kind of primitive, and that's called a machine. And think that you have a cluster, and you could actually tell the cluster to make a new node. Think you're in the cloud, and you could then say to the Kubernetes API server that, hey, I want a new VM to run Kubernetes on top of.
Okay, and then we create it.
And that's kind of the idea. So that that you inside of Kubernetes, you start using kind of Kubernetes as a database, as a fancy database, and in that Kubernetes database, you store the record on what kind of nodes you want to have, and then you have some reconciliation loop which checks the Kubernetes API. How many VMs should I have and with what configuration? And then I turn that into, GC or Amazon API calls, which then essentially, then boot up a new VM and which joins the cluster. So it's it's kind of a chicken and egg thing, and it's kind of really interesting to see, but it's again, one of the abstraction layers of how can we, abstract away some of the common things about, the environment we are in. So how can I could, make cluster API provider for my Raspberry Pi stack. And, if I say that, I want a new machine, I would instead have something, which electrically would, turn on, boot up one more Pi, stuff like that. In GC would be, create a new VM, but the similar in my environment would be that maybe. So those things, having said that, I will again come back to the extensibility, and I don't know if you've heard of the custom resource definitions.
Yes, that's how we do some of the deployments.
So it's essentially the thing which is like treating Kubernetes as a database. So let's say that you have operational knowledge on how to do a MySQL how to run a MySQL database. Okay, and now you want to run a MySQL database inside of your Kubernetes, Kubernetes cluster, and then you can create a custom resource definition which has the high level high level options of which you want to have. How many MySQL replicas should there be? How many peers, and like how many I don't know, availability zones and stuff like that. Some options on how it should do, what storage backend should it use, and stuff like that. And then you can create, once you have defined that schema, you tell Kubernetes, here is my custom type, which I want to be able to create objects of. And once you have registered that custom type to Kubernetes, you can start making objects using the kubectl Kubernetes command line client. You can just say kubectl create and then feed your file with your custom type. And Kubernetes will accept it and will have it there. And it's subject to all the normal authentication and authorization and everything that already exists. And then your application, which is running inside of the Kubernetes cluster, can then look at this, look at the desired state of your MySQL cluster, and it will turn the desired state high level into action calls to Kubernetes. First create this deployment with the MySQL initial replica, and then say that should be a write node, and then the operational loop will then create a couple of peers which will connect and be read only to that, and configure all that kind of stuff to make sure that it describes well, or it fits to the desired state. So, and that's called the operator pattern. So I think we will see more and more of those kind of things where you kind of use Kubernetes as a database for structured information, and you have controllers running inside of Kubernetes which actuate on that state. But they're entirely custom and they're entirely application specific. But they now can replace something which, people, going back to the initial question, why would you do that? Well, now you don't have to SSH in again, when that one machine is down, that one VM is down, and you have to load balance over your MySQL stuff automatically. Yeah, so now if you realize that, if you realize that in Kubernetes that one of the MySQL nodes are away, you just do a new call, make me a new MySQL replica here instead, and then I'll reconnect it. So it's like that kind of thing will definitely be one of the future things. And then I believe that we will see more of GitOps. I think that some extending GitOps maybe a bit more broader than Git. So I don't know what the right term is, but that kind of having things in a version way, with clear set of Excel control list and that kind of the transparency GitOps will be good.
Because the GitOps approach out outside the Kubernetes world anyway. Some people were already had it in place for some of the DevOps stuff, right? Whether they're using GitOps ways of doing the DevOps. And so as you mentioned, Kubernetes is the platform of platforms, right? Platform used to develop other platform on top. So Kubernetes becomes the operating system in a way, right?
Yes, exactly.
And in the old ways of deploying application on Kubernetes was using Helms, but now with the CRDs and operators makes it a lot easier, as you just mentioned. The platform becomes self-aware of how to create those new resources, right, and how to scale them, how to check them, how to make sure they're up and running. So looks very promising for Kubernetes at the moment, and the easiest for people to deploy it, the easiest for people to deploy in cloud or already, if it's already a service or managed service for the likes of EKS or Azure, Google, or if they just want to deploy it on bare metal, I mean, you've got to run on our Raspberry Pi, so there's no excuse. There's no excuse there.
Exactly.
All right. So it looks like it's very promising, and the adoption rate is really fast as well. A lot of people jumping on it at the moment and doing a lot of good stuff with it. So I think we going forward, there's a lot of good, promising things there that we'll be seeing. Right. So I don't want to take too much of your time now. I promised you it was going to be half an hour, but the conversation was so interesting that I didn't want to stop anywhere. And I could go on for another 2-3 hours. Right. So thanks, Lucas. Thanks, Lucas, for giving us this time to come on the show, Off the Chain. And any last words you want to share with everyone else before we part?
Last words would maybe be that, like if you're interested in Kubernetes, as the listener, I would encourage you to get involved. In some way, it could be, attending. Well, now now these days, it's maybe not attending a meetup in person, but attending a meetup virtually. There's many of those too, or webinar or similar. Getting in touch with the community, the ways they work. Kubernetes has 1 million meetings every week, so you can find your preferred special interest group there. Friendly people, like ask them about different things. Help if you want to help out. That's amazing. And yeah, it's been a fun ride. Engaging with that kind of open source. So yeah, I think that don't be afraid to contribute when you have ideas. We'll leave it at that.
All right. So thank again, Lucas. All right, and thank everybody else for listening. This was very interesting, very entertaining at the same time. See some of the complex stuff that Kubernetes actually solve. Hearing it from first hand for someone who's been working on it for almost since the beginning. So it was really great. So thanks again, Lucas. And thank you everyone for listening. And we'll catch you next time. Thank you all. Bye-bye.
Bye.